And also, it's important thing to understand that even with this implementation, our kernel is still telemetry agnostic, which means that it uses just pure .NET functionality. So there's no dependency to application insights or something. So our users will be able to use this kind of telemetry not only with application insights, but also with other libraries, like whatever they want.
You had me at no dependencies. Woohoo!
All right. Hello, everybody. I'm here joined with my colleague Dmytro, and he's going to be talking about semantic kernel and telemetry. Dmytro, do you want to introduce yourself and share what you work on the semantic kernel team?
Sure. Hey, everybody. My name is Dmytro, and I'm working on semantic kernel core team. And currently, at the moment, I'm working on the semantic kernel telemetry improvements. So today we are going to talk a little bit more our telemetry and the ways how we will improve that in the future as well.
Sounds good. Well, go ahead. The floor is yours.
I would like to present some example application, which is console application, where I'm using kernel instance. And basically, this example contains planner. And so my goal here is to create a plan and then execute a plan. But currently, the problem is that even if we execute a plan and receive some results, it's not really possible to see how it works under the hood in case of some issues. So we decided to implement and improve more observability inside semantic kernel and planner as well. So it will allow our users to check the logs or traces, for example, after the executed operation and see how it works, check the performance, for example, and then in case of any issues, troubleshoot it and see what happens.
Yeah. Before you go further, one of the initial takeaways I have is, yeah, one of the challenges that we've heard from users is just being able to have more transparency behind what's going on as you're making these calls to the large language model, as you're creating plans, as you're executing plans. So I think having better tooling around this, or just probably what you're going to show off here, I think that goes a long way to help solve this pain point.
Exactly. And this is a kind of a work in progress, and we are going to ship the first version soon. But of course, we are going to improve that in the future in order to meet our needs and our customer needs as well, in order to improve that transparency. So it will be easier to understand what's happening under the hood and also troubleshoot it. Here we have an example. So first of all, when we started to work on this task, the main priority was to think about data sensitivity. So we want to avoid logging some sensitive information for our customers. Here we basically have an example in .NET version. We have a plan to add similar things to our Python version and Java version as well. But in terms of .NET logging, there are basically some standards which is good to follow in order to implement observability in your application. So for that purposes, we use already existing log level categories. So basically, there are a couple of categories like trace, debug, information, warning, error, critical, and other things. So as per .NET official documentation, the information log level, it's default log level for your application. So as soon as you enable your logger, this kind of log level will be set for you by default. And the purpose of this this log level is to observe the general flow of your application and just see what happens. So this kind of logs shouldn't have any kind of sensitive information, and they provide some general kind of information. But for example, if you want some more detailed logs in case you have some issues and you want to understand what is happening, maybe you want to explore some sensitive data of your application and see how it works under the hood. For that kind of purposes, you can use trace log level. So these are the logs which contain the most detailed messages, and they may have sensitive data inside, and you should not use that log level in your production environment, although it's still possible. So as a user, you are responsible for setting up the logging configuration on your side and choose the appropriate log level for you. But semantic kernel telemetry is designed in a way that all the sensitive information will be logged as trace, but all kind of other general information will be logged for you as information. So we have this example here, and as soon as I run it as console application, it will put me this operation and or trace ID. So basically, this is a term which is used in distributed tracing, and it basically allows you to observe your scenario by some identifier. So for example, if you have some use case in your application and it is failing for some reason, you can open your logs and then search that application flow by operation ID. The one important thing to know that it is basically used across all of your distributed applications. So it's not used only in scope of one application, but for example, if you have like microservices or service mesh architecture, you should be able to observe how your application works and semantic kernel works in context of just one operation. So if we go to application insights, I already prepared some operation IDs just to show how it works in action. So for example, I have my first example, which uses only log level information. So basically, these are logs which will be stored for you by default. So let's try to find something here. So after I executed my console application, we can see some steps of the plan creation and also plan execution. So we can see here that plan creation started. So we use GPT-4 Azure OpenAI deployment model in order to generate that plan. We can see plan creation status like success or fail, for example, and we can see plan creation execution time. So it's important also to understand that these are not simple messages. So for example, if you expand that log, there's custom dimensions column, which basically allows you to store some custom properties specific to your logs. So for example, here we can see that it's actually a separate property and it has value success. It could be failed. So in theory, like you can go and write your extended query, which will use that property. So you'll be able to filter like all the operations which have a status success or failed. So you'll be able to troubleshoot it easier. And then, so the same thing for execution time, for example. So if we open this custom dimensions, it's possible to see this execution time in separate columns. So it should be possible for you to make a query which will allow you to understand, okay, which operations took more than 10 seconds, for example, right? That's another thing. And then if you go, so after our plan was created, we passed that plan to Semantic Kernel, and it basically executes it. So we can see here that we used writer skill and short poem function to execute some step of that plan. So for that step, we also used the GPT-4 model, and we see step execution status, which is success in this case, and we also have this step execution time. And then, so in our generated plan, we had basically two functions. So translate is the second function, and we have similar logs here. Now, these are kind of logs which will be available for you by default, and most probably, so of course we are going to extend them, but it's the first version, and this kind of logs will be available for you for production, in your production environments. So you will be able to understand the flow of planner and the semantic kernel. But then if you want more details, you can enable trace logging in your demo or test environment, for example, and this will allow you to get some more context. So first of all, we have this, we have similar structure, a log structure, but it's extended a little bit. So we have this plan creation started, and then we are able to see what actual goal we used in order to generate that plan. So in this case, we want to write a poem about some person and then translate it to Italian, right? Then we are able to see extended logs from the kernel itself. So for example, we are able to see what kind of prompt was sent to the AI model to generate that plan. So we are able to go through it and see how does it look like. And then we also see like the same thing, like we use GPT-4 model and then plan creation status. And then we are able to see the generated plan. So for example, for that goal, we see that we have the plan to use writer skill and short poem function with some parameters. And then also based on that result, we are going to translate that to Italian language. And so the similar thing we have for the function or step execution. So we are able to see what kind of prompt we sent in order to generate that short poem. And in terms of translate function, we are able to see like what kind of prompt we sent to AI model to translate that short poem. So that's basically how does it look like in terms of logging. But also what we can do here, we can go to the transaction search, for example. I already have this tab opened, and we are able to grab that operation ID and paste it to transaction search and try to search by that operation ID. So I already did that. And here we'll be able to see similar logs, which are basically a little bit extended. On the right side, in the custom properties, we are able to see the execution time of particular step, for example, or for plan creation. So all of that information is available for you. There is also some internal logging of what kind of HTTP request we did to AI models. So for example, here we did API call for to Azure OpenAI. So it took like 7.5 seconds. This is HTTP request. We get our success status code and all of this kind of things. This kind of transaction view is also helpful because it has the ability to show this timeline breakdown. So for example, there were 3 steps in our operation. So first of all, we generate plan and then we execute them by executing 2 functions, and we are able to see like 3 calls to Azure OpenAI with more detailed breakdown, like how much time did it take to perform specific operation. So yeah, so that's regarding the transaction details. And also we have some metrics here. And of course, all of this is basically initial version. We are going to extend it in the future, but basically you can create your own dashboard with some custom metrics. So for example, if you want to see how much time did it take to generate a plan, you are able to find this custom metric called sequential planner.create plan.execution time, which will allow you to see performance of your plan creation. So for example, if you are not satisfied with these metrics, you can go and fine tune your goal, for example, and maybe your new goal will perform a little bit better. So that's one thing. And also we are able to choose metrics for a specific function. So for example, if I have this function to generate a short poem, I can select it and I will be able to see metrics for this specific function. Let's say I have 10 functions in my solution and I want to see just general picture how my functions are working in production environment. I'm able to add another custom metric for second function, which is translate. So I am able to see general picture like how my functions are performing. And for example, if I see some spikes, I should be able to go to my function, modify it a little bit, deploy it, and then see whether the issue was resolved or not. I believe this is all regarding the SK telemetry at the moment, but of course we are going to extend it in the future with some more details. So it will allow to see some basically more logs and more metrics, and in theory it should improve your service observability as well as observability of the semantic kernel.
Very good. Where can people find this inside the repo?
Yeah, so it's going to be located under the samples folder under .NET solution, because currently it exists only for .NET, but in the future we are going to add the same thing for Python versions as well. And the other important thing that semantic kernel is telemetry agnostic, which means that you can always attach your own telemetry tool based on your preferences, because application insights is just like showcase what is possible. With this implementation, you should be able to choose other tools as well, because for that functionality we used plain .NET libraries. So
yeah, I think that sounds good. I think a major point then is that it has very minimal dependencies to be able to get started, to get using it, and then people can just bring in their own, like app insight type service and hook it up.
Exactly. Yeah.
Okay, great. Well, I mean, this is very good. Thank you so much, Dmytro, for walking us through it. I guess last question to you is, it's a question I'd like to ask all the people from the Semantic Kernel team is, if you were to give some advice to people building an AI application, since you've been doing so a lot lately, what piece of advice would you give?
That's an interesting question. So I would definitely advise people to explore the opportunities to use AI in their applications, because I'm pretty sure with current capabilities, it is possible to cover a lot of different business scenarios and cases. And if you want this process to be easier for you, you can take a look at Semantic Kernel repository and see if that helps. And of course, if in case you will have some issues, you're welcome to ping us directly, and we will try to help.
Very good, very good. But cool. Well, thank you so much, Dmytro, again. And yeah, looking forward to playing around with some telemetry with Semantic Kernel.
Thank you.
All right, take care.